Hey there, 10-year-old trainees, and welcome to today's Explainer. I am so excited you're here. Today, we are going to do something pretty amazing together. We're taking what you might think are just boring science rules from your textbooks, and we're turning them into exciting, real-world detective tools. That's right. By the end of our time together, you won't just be students anymore. You are going to be certified science detectives ready to solve everyday mysteries. All right, let's dive right in. Okay, let me ask you something. Have you ever wondered what the actual secret is to building the ultimate farthest flying paper airplane? Like, why do some of them crash literally the second they leave your hand, while others just glide all the way across the classroom? Well, I'll let you in on a little secret. It's not magic, it's science. By mastering the 12 science process skills we're covering today, you'll have the exact power and knowledge you need to build that ultimate airplane. So grab your mental magnifying glasses and let's get started. Section 1. Be a science detective. Gathering your first clues. Now, every single great investigation, whether you're Sherlock Holmes solving a crime or a scientist working in a lab, starts with gathering solid clues. And the best part? You do this using the built-in detective tools you already have. The very first science process skill is called observing. But hey, observing isn't just looking with your eyes. It's using all 5 of your senses. It's using your sense of smell to detect exactly what's cooking for dinner before you even walk into the kitchen. Or it's using your sense of sight to carefully watch an ice cube melting on a plate. When we observe, we're basically just collecting the raw clues for our mystery. So once you have your clues, you've got to figure out what they actually mean, right? That brings us to our second skill, inferring. Think of an inference as a smart detective guess that explains exactly why something just happened. Let's go back to that ice cube. Let's say you used your observation skills and saw that the ice cube on the plate melted incredibly fast. Well, your detective brain kicks in and makes an inference. It melted fast because it was left out in the hot sun rather than sitting in a cold, air-conditioned room. You didn't necessarily see the sun melt it, but based on your clues, it's the smartest explanation. And, this brilliantly illustrates our next skill, predicting. While inferring explains what already happened, predicting is making a smart forecast about what's going to happen next. It's kind of like being a weather forecaster. If you see the ice is melting fast in the bright sun, you can safely predict that in another 10 minutes, that ice cube is going to be nothing more than a puddle of water. You're just using your past experience and your current clues to basically look into the future. Pretty cool, right? Section 2, measuring and organizing clues. Tools of the trade. Okay, so as we gather all these awesome clues, things can get pretty messy. And a good detective absolutely needs the right tools. Our official training manual, the curriculum document, shows us that these exact skills, like predicting, interpreting data, and defining things operationally, are absolutely crucial for solving cases. We're not just making this stuff up, guys. This is your official roadmap to becoming a total science master. So how exactly do we organize our clues? Well, we use a really handy skill called classifying. This just means sorting things into groups based on their physical characteristics. If we're investigating plants, for example, we can group those with sharp thorns, like a durian tree, and beautiful roses, together on one side. Then, on the other side, we can group plants that produce sticky sap, like papaya and yam plants. By classifying, we take a messy, chaotic pile of clues and turn it into a neat, perfectly organized filing cabinet right in our minds. But here's the thing. Sometimes simply looking and sorting just isn't enough. We need exact numbers. And that brings us to measuring and using numbers. A true science detective doesn't just look at a plant and say, "Wow, it grew a lot." Nope, a detective uses a ruler to measure the exact length in centimeters. Or if we're doing an experiment with heat, we don't just guess and say the water is hot. We use a thermometer to get the exact temperature. Using standard tools makes our observations totally precise. No guessing allowed. Moving on to Section 3, the secret of variables, finding cause and effect. All right, trainees, get ready because we are about to unlock the most powerful detective tools of the whole day. Now, I know the word variables sounds really intimidating, but let's demystify it right now. Variables are literally just the different ingredients in our mystery. That's it. They're simply the specific parts of an investigation that we can change, that change on their own, or that we have to keep exactly the same to make sure our test is completely fair. Just ingredients. Now, there are 2 main types of variables you need to know if you want to find cause and effect. First up is the manipulated variable. This is the cause. It's the one thing we choose to change. For instance, if we're building an electric circuit,
The manipulated variable might be the number of dry cells or batteries we're using. Then we have the responding variable. This is the effect. It's what happens because of our change. In our circuit example, the responding variable is the brightness of the light bulb. If we add more batteries, the bulb shines brighter. It's just cause and effect.
So the absolutely crucial point here is that once we know our variables, we can make a hypothesis. A hypothesis is your big, grand detective theory. It's a statement that links what you change to what you expect is going to happen. It's a testable guess. For our circuit, our hypothesis would be super simple. If we use more dry cells, then the bulb will be brighter. See? You just state your cause and you guess your effect. Section 4, the paper airplane test. Testing the theory. Okay, detectives, it's time to use the ultimate skill, experimenting. Let's finally return to our epic paper airplane mystery. Experimenting is honestly just following a simple recipe. Step 1, identify the problem. In this case, we want to know what makes a paper airplane fly the furthest. Step 2, make a hypothesis. Step 3, control the variables. And step 4, run the test and collect the data. Let's walk through this whole shebang together. First things first, we've got to set our variables so we know exactly what we're changing and what we absolutely must keep fair. Our manipulated variable, the thing we're changing, is the size of the paper airplane. We'll make a small, a medium, and a large one. Our responding variable, what we're trying to find out, is the distance flown. And our constant variable, the thing we must keep the same so it's a fair race, is the exact type of paper we use. I mean, we can't use thick cardboard for one plane and thin tissue paper for another, right? That wouldn't be a fair test at all. Now hold on, before we throw a single plane, we have to use a skill called defining operationally, which is really just a fancy science way of saying we need to set a strict rule for how we're going to measure the winner. For our airplane test, defining operationally means stating the distance flown will be measured using a tape measure, tracking in centimeters from the start line to the exact spot where the nose of the airplane hits the ground. Boom, now everyone knows the rules, and there's going to be absolutely no arguing over who won. Section 5, reading tables and graphs, decoding the secret message. All right, we threw the planes, measured the distances, and collected our clues. But a great detective doesn't keep secrets. They have to share their findings. This involves the skills of communicating and interpreting data. Here's our raw data from the airplane test. Let's decode it together, row by row. In the first column, we have the size of the airplane. In the second, the distance flown in centimeters. Look at that top row. The small 10-centimeter plane flew an amazing 30 centimeters. The medium plane flew 20. And the large plane? Only 10 centimeters? No way! Surprisingly, our data tells us that the absolute smallest plane actually flew the farthest. And this brilliantly illustrates how we can turn those raw numbers into a picture, like a bar chart. See how the table directly translates to these bars? The tallest bar belongs to the small plane, stretching all the way up to the 30-centimeter mark. By communicating our data in a graph, literally anyone can just glance at the screen and instantly see the result of our experiment. The visual just makes interpreting the data incredibly easy and fast. Section 6, Science in Everyday Life. The world is your laboratory. Wow, we've gone through the 12 tools of discovery, and you guys have done wonderfully. But before we wrap up, I want you to realize something really important. These amazing detective skills, they aren't just for textbooks, and they definitely aren't just for science class. They're for solving problems in your daily life. You're already using them all the time without even realizing it. When you figure out why your favorite toy stopped working, you're inferring. When you help bake a delicious cake in the kitchen by adding the exact right amount of flour and sugar, you're measuring. And when you build the perfect paper airplane to race your friends in the backyard, yep, you are experimenting. Honestly, you guys are already natural-born scientists. The only difference is that now you have the official training manual right there in your head. You know the exact names of the tools you're using, from observing all the way to hypothesizing. So my final challenge to you is this. What everyday mystery will you solve next with your brand new science detective tools? The world is absolutely full of fascinating puzzles just waiting for a smart detective like you to figure them out. Thank you so much for joining me in this explainer, trainees. Now go out there, start observing, and I'll catch you on the next investigation.